Okay, I hope everything is working correctly. Welcome to Bite Me, where we're squashing bugs one bite at a time. I'm your host. My name is Jillian. This is going to be the first time I'm streaming on YouTube and on Twitch, so hopefully everything is working. Let me just double check. Okay, I think it's working. Let's hope it is. Alright. So today we're going to get started on, we were doing chapter 6, so we're going to get started on 6.2. This is enums and pattern matching. Let's see what we did last time. Okay, this kind of just went over what was enums and everything like that. And I think we're just going to get into the nitty gritty of pattern matching and using match statements in this episode. So if you haven't seen my other videos, you can go to my YouTube. It's also called Bite Me. It's in the description. If you're watching on YouTube, then you can watch my other lives. It's within the Error 404 playlist. Once I get to a certain amount of subscribers, supposedly on Twitch, I'm able to re-upload the previous YouTube streams that I've done. So let's hope that I get to that point so I can actually start uploading and people can actually see my previous lives. All right, let's jump into today. This is 6.2. All right, so concise control flow with if let and let else. The if let syntax lets you combine if and let into a less verbose way to handle values that match one pattern while ignoring the rest. Consider that the program in listing 6-6 that matches on the option U8 value of the config_max variable, but only wants to execute code if the value is the sum variant. I think in the last episode we were talking about the option. I think that's what we're doing, or that may have been Structs. It was last week, so my brain is not completely gonna remember what we did last week, but we did do option pattern. Now we're gonna do like if let, the if let control flow. So here we have an example. Let config_max equal sum, and then we got a 3U8. Okay, now that we're matching on that config max variable that we just bound to sum, and then we're having this hold max, and then if we're going to print line, the maximum is configured to be max. And then over here, which this means that anything else other than sum is going to not return anything. Okay? If the value is sum, we print out the value in the sum variant by binding the value to the variable max in the pattern. We don't want to do anything with the none value. To satisfy the max expression, we have to add the underscore and then I call it the fat return, because it's instead of like one return, it has both, it has double. So the fat return after processing just one variant, which is annoying boilerplate code to add. Now instead we can write in a shorter way using if let. The following code behaves the same way as the match statement above. So we did do a couple of match statements in chapter 2. Remember, the match statement has to satisfy all possible returns, or all possible statements. And that's why we use this little underscore, because it satisfies all possibilities. Now let config_max equals sum 3U8. If let sum, and then we're holding max as a parameter, equals config underscore match max, what is our variable. Then we're going to print line the maximum is configured to be max. Now, the syntax if let takes a pattern and an expression separated by an equal sign. It works the same way as match, where the expression is given to the match and the pattern is the first arm. In this case, the pattern is sum with max as a parameter or an argument. And the max binds to the value inside the sum. We can then use the max in the body of the if let block to let some way we use max in the corresponding match arm. Okay, so the code in the if let block only runs if the value matches the pattern. Using if let means less typing, less indentation, less boilerplate code. However, you lose the exhaustive checking match enforces that ensures that you aren't forgetting to handle any cases. Okay, because that you have to have all match statement cases as all possibilities, you have to make sure you have an exhaustive checking. So it says over here that it ensures that we aren't forgetting any forgetting to handle any cases. So we have to handle all cases. So the if let lets us handle all cases without putting that underscore, which also handles all cases. Choosing between match and if let depends on what you're doing in the particular situation and whether gaining conciseness is an appropriate trade-off for losing exhaustive checking. In other words, you can think of if let as a syntax sugar for a match that runs code when the value matches one pattern and then ignores all other values. So the if let is only matching on one specific pattern, but it's also satisfying all of the possibilities. We can include an else with an if let. The block of code that goes with the else is the same as the block of code that will go with the underscore case in the match expression that is equivalent to the if let and else. Recall that coin enum definition in listing 6-4, where the quarter variant also held a us state value. If we wanted to count all non-quarter coins, we will see while also announcing the state of the quarters. We could do that with a match statement or a match expression like this. Let mute, let's bring this up. Let mutable variable count bind to 0. Then we're going to match on coin. Now we're using the coin for this match expression. I'm pretty sure it said that they had a coin enum. So we're using that coin enum to match quarter, which is a state, as a parameter. And then print line state quarter from whatever state it's from. Let's say Florida. Then here's our match statement that satisfies all possibilities. Then we're going to do our fat return, which is count and increment by 1. Now, or we can use an if let statement and an else expression like this. So we're doing the same thing. We're making a mutable variable called count and bind to 0. If let coin, which is quarter, and then state, let's say state is Florida, equals coin. We're going to print line state quarter from Florida in pretty print. And then we're using this else statement to count increment by 1, essentially. We're using this count to increment by 1. So if it doesn't equate to this, then it will increment. Now, staying on the happy path with let and else, the common pattern is to perform some computation when a value is present and return a default value otherwise. continuing with our example of coins with the us state value, if we wanted to say something funny depending on how old the state of the quarter was, we might introduce a method of us state to check the age of a state, like so. Okay, so we have our IMPL block or method, and this is using this is named us state. Okay, now we have a function within our method that's called existed in. We are using one of the parameters as self, and then we are also having a parameter called year, which is using a unsigned 16-bit integer. And we're going to return a bool, which is a boolean, also known as true or false. We're doing a match on self. And then I'm pretty sure this is an enum. We're doing an us state. We're matching over here on Alabama, we're doing a fat return with the year, and that is greater than or equal to 1819. Okay, same over here. We're doing Alaska with a fat return of the year, and it's going to be greater or equal to 1959. Now, then we might use if let to match on the type of coin, introducing a state variable within the body of the condition as listing in 6-7. So here we can see 6-7. We have function describe state quarter, which is a parameter of coin. We have in this parameter, and we're matching on that previous enum. Do you remember? We're not. Okay, so we have our parameter coin, which is going to use coin, the enum, as an argument. Return option string. So if let coin, and then we're matching on one of the, I think they're called, not called fields, they're called instances. I think they're called instances in enums. We're calling the quarter instance with the state as a parameter, and then we're equating it to coin. Now, if state, and then we're indexing state by existed underscore in 1900. We have some as, let's say, okay, so we're using the if let over here, then we're putting in an if statement with else. So we have like an embedded, it's like nested in the if let, okay? So some format, and then we do our state in pretty print is old for America. Else some format, which is a state which is relatively new. All right, and then we're actually using this else from this if let statement. Else is none. So let's see what it says. People are trying to call me. Not letting that happen. Okay. That gets the job done, but is pushed. See, this is a bit confusing right here. If we might use an if let to match on the type of coin, introducing a state with the body of the condition. I hope it goes into a little bit more detail because I'm a little bit confused as to why we have an if let. Then we have an if and else statement within the if let, and then we're utilizing else to return none. I guess it does make sense because where did we have existed in? We have this function existed in. Okay. So within this function, within our method, we are indexing this parameter as 1900. If state dot existed in, I guess there are more states. So if there are more states within this function, it's probably something that's going to have 1900 on it. Then it'll be returned over here. And then this format macro, I think it's formatting within the terminal. I haven't used this format macro before, so I'm not exactly sure what it does, but I have a hunch that it is formatting something within the terminal based on this print. Okay, that gets the job done, but it has pushed the work into the body of the if-let statement, and if the work to be done is more complicated, it might be hard to follow exactly how the top level branches relate. Yeah, it's a little bit difficult. We could also take advantage of the fact that the expressions produce a value whether to produce the state from the if-let or to return early, as in listing 6-8. You could do something similar with the match too. Okay, so within this 6-8 we have a function describe state quarter. We have a parameter called coin, and then we're utilizing that enum coin. Returning option string. We got a let state equal, so we're binding state to an if let, which is going to utilize this enum, see this instant quarter, and use state to equal coin. Now, within this, we also have state. So I guess we are just returning state as an expression. Okay, then our else statement return none. Now, if state dot existed in is 1900, then we're going to do some format macro, and then we're printing the state. It's pretty old for America, else if it's not 1900, then we're going to be printing the same format. Whatever state it is, it's relatively new. Now this is a bit annoying to follow in its own way though. One of the branch of the if-let produces a value and the other one returns from the function entirely. To make this common pattern nicer to express, Russ has the let else. The let else syntax takes a pattern on the left side of the branch on the left side and an expression on the right, very similar to the if-let, but it does not have an if branch, only an else branch. Okay. If the pattern matches, it will bind to the value from the pattern in the outer scope. If the pattern does not match, the program will flow into an else arm, which must return from the function. Okay, so we have another one. Let's see. So function, describe state quarter. Oh my God. We did 6.3, not 6.2. We might have to go back. That's why I was a bit confused as to why these match statements were so, well, these weren't really match statements, are they? Okay. So the listing 6-9, you can see here, function describe underscore state quarter. We have a parameter, which is coin. We're returning an option, which our option is string. And then we let coin, which is our enum, look at one of the instances, which is a state, and then coin else, return none. So we're not even using the if let, we're just using let else. Now if state dot existed in, which is one of our functions within previous section. I hate that it's all the way over here. Existed in is a function that we had in this method, which is returning a U16, which is the year U16 if it's true or not. Now we have a state, which is, actually we're going to run this. State, which is Alaska, is pretty old for America, else format state is relatively new. So you're going to see what state it is, which is Alaska, or what was the other one? Alabama or Alaska. And you can see that Alabama is greater than or equal to 1819. Alaska is greater than or equal to 1959. So it chose Alaska because it existed in 1900, which is true, and it's going to put is relatively new. Okay. Notice that it says on the happy path and the main body of the function this way without having significantly different control flow for two branches in the way that if let did. If you have a situation in your program, situation in which your program has logic that is too verbose to express using a match, remember that if let and let else are in your Rust toolbox. Okay, we're gonna have to go back. Okay, we're gonna have to go back to match control flow because we did not go through this. And that's my bad. I was supposed to go through this first, so I guess it doesn't really matter. But let's go through it and we can finish up Enums today. And then tomorrow we will start on packages and crates fresh, okay? The match control flow construct. So Rust has an extremely powerful control flow construct called match, and this will actually help what we just learned. That allows you to compare a value against a series of patterns that execute code based on which pattern matches. Patterns can be made up of literal values, variable values, wildcards, and many other things. Chapter 19 covers all the different types of patterns and what they do. The power of match comes from the expressiveness of the patterns and the fact that the compiler confirms that all possible cases are handled. Think of the match expression as being like a coin sorting machine. Coins slide down a track with variously sized holes along it, and each coin falls through the first hole it encounters that it fits into. In the same way, values go through each pattern in the match, and the first pattern and the value fits. First pattern the value fits, the value falls into the associated code block. Essentially, order of operations. Whichever value that it fits first is going to only execute that code block. And then it's done. It's completed. So usually you want to do lesser values first because you know that if it's a greater value and let's say it's a lesser value than a specific, you know what, actually, let's just keep reading because if I explain this, it's going to explain it again, and I have a tendency to over-explain. Okay, think of a match expression as being coin, blah, blah, blah. Okay, speaking of coins, let's use an example using match. We can write a function that takes an unknown US coin and it, in a similar way as a counting machine, determines which coin it is and returns its value as cents. Okay, so we have an enum called coin. We have penny, nickel, dime, quarter. And function values in cents, we're going to have this coin parameter, which is also referring to our coin enum, and we're returning a U8 number. Now we're matching on coin. Now we have penny, which is 1, nickel, which is 5, dime, which is 10, quarter, which is 25. Now let's break down the match in the value in cents function. First, we list the match keyword followed by an expression, which in this case is the value coin. It seems very similar to the conditional expression used with the if, but there's a big difference. With the if, the condition needs to evaluate the Boolean value but here it can be any type. Type of coin is the example in the coin enum that we defined in the first line. Next are the match arms. An arm has two parts, a pattern and some code. The first arm here has a pattern that is a value of coin, which is penny, and then a fat return, that's what I like to call it, operator that separates the pattern and the code to run. The code in this case is just the value 1. Each arm is separated from the next with a comma. When the match expression executes, it compares the resultant value against the pattern of each arm in order. Now, if the pattern matches the value, the code associated with that pattern is executed. Remember this. If the pattern doesn't match the value, execution continues to the next arm. Much as coin sorting machine, you can have as many arms as you need. Now in listing 6-3, our match has 4 arms. The code associated with each arm is an expression, and the resultant value of the expression is the matching arm. In the matching arm is the value that gets returned for the entire match expression. Okay, we don't typically use curly brackets if the match arm code is short, and it is a listing of 6-3 where each arm just returns value. If you want to run a couple of lines of code in a match arm, you can use curly brackets, and a comma following the arm is then optional. For example, the following code prints lucky penny. Every time the method is called in coin, penny, but it still returns the last value of the block. 1. All right, here we go. So we have a function called value in cents. We have a coin that we're being passed as a parameter, coin, which is also our enum, and then we're returning a U8, unsigned integer. Now match on coin, let me take off this jacket because it's making me hot. Okay, so we're matching on coin, and then we're utilizing our enum by matching on this instance called penny, and we're print lining lucky penny, which is 1. A penny is 1 cent. Then we have coin nickel, which is 5, coin dime, which is 10, quarter, and which is 25. So I feel like that's a little bit self-explanatory. Let me make sure. Okay. All right. I just want to make sure that my Twitch is still streaming. It says I'm live. I don't know how to use Twitch that well, so let's hope I'm using it correctly. Okay. Patterns that bind to values. So another useful feature of the match arm is that they can bind to parts of the value that match the pattern. This can also, this is how we can extract values of an enum variant. As an example, let's change one of the enums and the variants to hold data inside. From 1999 through 2008, the United States minted quarters with different designs for each of the 50 states on one side. So no other coins got state designs. So only quarters have this extra value. We can add this information in our enum by changing this quarter variant to include a US state value stored inside of it, which we've done in listing 6-4. So here we have we have 2 enums actually. This enum is an US state, which has both states, Alabama and Alaska, and then we have our coins. But we're utilizing the US state enum within our enum, our coin enum. see. All right. Now let's imagine that a friend is trying to collect all 50 state quarters. While we sort our loose change by coin type, we can also call out the name of the state associated with each quarter so that if one of our friends doesn't have one, they can add it to their collection. Now in the match expression for this code, we add a variable called state to the pattern that matches values of the variant coin quarter. So we're matching on quarter based on the state. And you can see up here, you see how we're utilizing this within our quarter? We're doing the same thing down here. This is now our parameter. Oops. This is now a parameter within the quarter enum, in the instance of the quarter enum. All right. Where was I? In the match expression for this code, we add a variable called state to the pattern that matches the values of the variant in coin, quarter. When coin, quarter matches, the state variable will bind to the value of the quarter state. Then we can use the state in the code for that arm like so. So here we have function, value in cents. We're utilizing this parameter called coin, and then over here we're utilizing the enum that we have named coin and putting it as an argument. We're returning a U or an unsigned 8-bit integer, and then we're matching on coin over here. We are seeing all these instances with penny, nickel, and dime and quarter from the enum. So we're utilizing the previous enum that we created over here. We're doing it over here again. Okay, we're actually returning 1, 5, 10, and over here on the quarter, we're returning a state. And print lining state quarter from this specific state is 25. 25 is used as an expression because, see, it's after this colon. So we are returning that 25, but we just don't have to put another comma at the end. If we were to call value in cents, where coin, quarter, and US state, Alaska, coin would be coin, quarter, US state, Alaska, okay? Let's see. So you're calling the function, oh, sorry, did not mean to do that. Let's go back. My bad. So we're calling the function, it said it would be, which is this. It's essentially saying the same thing, just this we're calling the function, and then this is just a part of the function. We can compare the value, which each of the match arms, none of them match until we reach, people are bothering me so much today. We can then use where am I? At that point, the binding for state will be the value of US state in Alaska. We can then use the binding of the print line expression, thus getting the interstate value out of the coin enum variant for quarter. Cool. Now we're going to talk about option T. Okay, so in the previous section, we want to get to the inner T value for the sum case when using option T. Now, as we talked about in the previous episode, option T is a substitution for null in the Rust language. So we're not utilizing null anymore because of all the errors that it can possibly have during runtime or compile time. We utilize option T instead. Okay. So we handle option T using match as we did with coin enum. Instead of comparing coins, we'll compare the variance of option T. But the way that the match expression works remains the same. So let's say that we want to write a function that takes up option I32. And if there's a value inside that adds 1 to the value, if there isn't a value inside, the function should return the none value and not attempt to perform any operations. Now, this function is very easy to write thanks to match, and we'll look at the listing of 6-5. So within this function, we have +1, which is our function name, and then we have a parameter of x, which is utilizing the option 32. We're also returning option 32, so that's what we want to see within our terminal. Match on x, so we're matching on this parameter. Then we have none, we're doing a fat return on none. And then we have sum, which is equal, has an argument of I, and we're returning on sum, which is I plus 1. Then we have let 5 equals sum with an argument of 5, let 6 equal plus 1, which is 5. This variable 5 is utilized here. And then let none equal plus 1 with none as an argument, okay? Now let's examine the first execution of the +1 in more detail. We can call +1 with 5 as a parameter, and that's a variable 5. The variable x in the body of +1 will have the value of sum, and then it has 5 as the parameter. And we'll compare that against each match arm. So we have none returning none, and then sum 5 value doesn't match the pattern of none, so we continue to the next arm. So it goes from each arm to see if it matches correctly on that specific arm. If it doesn't, then it goes to the next one. Although if it says, let's say it matches on an arm that is first, and it also can match on an arm that's maybe third or fourth, it's going to always match on that first arm, and it will execute that code and exit that block. Okay, the sum value doesn't match on none, so we can continue to the next arm. So we have sum with the parameter of I using a fat return, which is sum I plus 1. Now, does sum 5 match sum I? It does, because I is never really determined. We don't know what I is. It's the same thing as 5, essentially. It does. We have the same variant, and I binds the value that's contained in sum. So I takes the value of 5. Now the code on the match arm is then executed, so we can add 1 to the value of I and create a new sum value with the total inside is 6. So we have 5, which is sum, and we also have I. So we're actually, you see this argument that we're putting in sum, we're actually putting it into this one as well. We're utilizing the variable 5 as putting in the number or integer 5 here, and then we're returning sum, which is 5 or I plus 1, which is 6. So that's a total. Now let's consider the second call of +1 and listing 6-5 where x is none. We enter the match and compare to the first arm. +1 is, okay, we're calling the function +1 and we're just matching on this specific arm here. So it's the same thing. It matches. There's no value to add to. So the program stops and returns the none value on the right side of the fat return, because the first arm matched, no other arms are compared. Combining match and enums is useful in many situations, and you'll see that the pattern a lot in Rust code. Match against an enum, bind a variable to data outside, then execute the code based on it. It's a bit tricky at first, but once you get used to it, you'll wish you had it in all languages. It's consistently a user favorite. Okay, so matches are exhaustive. And I'm pretty sure this is the point where we're going to be talking about, the placeholder. So let's look at this one. So there is one other aspect of match we need to discuss. The arms patterns must cover all possibilities. Consider the version for a +1 function which has a bug and won't compile. So we have function +1. We have a parameter which is x, which is returning an option I32 here. We are matching on x, and we have some I returning some I+1. Okay, we didn't handle the none case. So when you're having an option or you're matching on anything, you have to have a sum and a none in every single instance, because that none is utilizing or exhausting all possible possibilities. Now, luckily, it's a bug, and Rust knows how to catch it and if we try to compile this code. So it will always tell you if it's having an issue, and it will give you some sort of solution within the compiler. So you can see here we have pattern none not covered, and then it's telling you what to do. So we have some I as parameter, return some I+1, and then over here we have none when we're returning to do macro. Right? Okay, perfect. So Rust knows that we didn't cover every possibility case, and even knows which pattern we forgot. So matches in Rust are exhaustive. Now, we must exhaust every possibility in order for that code to be valid, especially in the case of option T, when Rust prevents us from forgetting to explicitly handle the none case. It protects us from assuming that we have a value when we might have null, thus making $1 billion mistake discussed earlier impossible. Here we're going to talk about placeholders. So this is one part which makes the match statement most exhaustive. So using enums can also take special actions for few particular values, but for all other values, take one default decision. Imagine we're implementing a game where if you roll 3 on a dice roll, your player doesn't move, but instead gets a fancy new hat. Now, if you roll a 7, your player loses a fancy hat. For all the other values, your player moves that number of spaces on the game board, where a match, here's a match that implements logic. So with the results of dice roll hard-coded rather than random value, and all other logic represented by functions with bodies, because actually implementing them is out of scope for this example. All right, here we have a let dice roll. We're binding it to the number 9. We have a match statement named dice roll. And then we're utilizing 3, returning add fancy hat, whatever method is the add fancy hat. And then we have a 7, which is remove fancy hat method. And then we have other, which is kind of our anything else that is happening, the move player with other. Okay. Then we have a function add fancy hat method over here, function remove fancy hat method over here, and there's no returns, there's no parameters, There's not even anything in the function. We have function move player, and then with other, and then we have a parameter which is num spaces. This is u8. So if anything, other would be a unsigned 8-bit integer. Okay. For the first two arms, the patterns are literal values of 3 and 7. For the last arm, they cover every other possible value. The pattern is the variable we've chosen to name other. The code that runs for the other arms uses the variable by passing in the move_player function. All right, so this code compiles even though we haven't listed all the possibilities, all the possible values a UA can have, because the last pattern will match all values not specifically listed. This catch-all patterns meets the requirement that match must be exhaustive. Note that we can have to put the catch-all arm last because the patterns are evaluated in order. If we want to catch all arm earlier, the other arms would never run. So Rust will warn us if we had add all arms after a catch-all. So Rust also has a pattern in which we can use to catch all, but don't want to use the value in the catch all pattern, which is an underscore. It is a special pattern that matches any values that did not bind to the value. This tells Rust we're going to be using the value so that Rust won't warn us about an unused variable. So let's change the rules of the game now. Now, if you roll anything other than a 3 or a 7, you must roll again. We no longer need to use this catch-all value, so we can change our code to use the underscore instead of variable named other. Oh, somebody did comment. I didn't even see this. So Rust language study sesh. Little heart. Thank. Okay. I didn't see the comments. I just answered it. I've never actually gotten a comment on any of my lives before because I was only posting on YouTube. So this is like my first time posting on Twitch, and I'm quite excited because, yeah, this is my first time. I've never even responded to a comment before. So, alright, cool. We're almost done. So, let's change the rules of the game. Remember, we're doing anything other than a 3 or 7, you must roll again. We no longer use the catch-all value, so we can change our code to an underscore instead of a variable named other. So the other was a catch-all value. So we have let dice roll, which is bound to 9. We're matching on dice roll. Then we're doing 3 is a fat return on add fancy hat, the method or function over here. Then we have 7 doing a fat return on remove fancy hat on the function over here. And then we also have reroll, which is utilizing, what is this? Our catch-all pattern, okay? Our special pattern. And we're doing a fat return on reroll function, okay? So anything other than a 3 or a 7 must have a reroll. And remember, our dice roll is a 9. So we're mashing on this dice roll. We're definitely going to have to reroll. I just want to see what it has no output. I like when it has a print line so we can see what's going on. Yeah, sometimes it just doesn't have that. So this also meets the exhaustiveness requirement because we're explicitly ignoring all other values in the last arm. We haven't forgotten anything. Finally, we changed the rules of the game one more time so that nothing else happens on your turn if you roll anything other than a 3 or a 7. We can express that by using the unit value, the empty tuple type we mentioned in tuple type section, as a code that goes with the underscore arm. So here we have another let dice roll, 9 to 9. We're matching dice roll on 3 and 7. 3 and 7 have two of the functions that are down here, which is add fancy hat and remove fancy hat. Lastly, we're going to have our catch-all, which is returning nothing. So it's not going to return to reroll, we're just returning nothing. It's empty. It's okay. Now, here we're telling Rust explicitly that we're going to use any other value that doesn't match a pattern in an earlier arm, and we don't want to run any code in this case. There's more about patterns and matching that we'll cover in chapter 19, but for now, we're going to move on to the if-let syntax, which we already kind of went through, which can be useful in situations where a match expression is a bit wordy. So we already went through the if-let expression. Let's just read the summary. We've covered how to use enums to create custom types that can be one of a set of enumerated values. We've shown how the standard library's option T type can help you type the system to prevent errors instead of using null. When enum values have data inside them, you can use a match or if-let to extract. Use those values depending on how many cases you need to handle. And your Rust programs can now express concepts in the domain using structs and enums. Creating custom types to use your API ensures type safety. Now the compiler will make certain your functions only get values of the type each function expects. In order to provide a well-organized API in your users that is straightforward to use and only exposes exactly what your users will need, let's turn to Rust modules. So we're going to be going through packages, crates, modules in the next video. Hopefully that you stay tuned for that. Hopefully you stay tuned for the next videos. If you do want to go back, especially if you are on Discord, I highly recommend going through my YouTube channel. All of my lives, my previous lives are there. I also have a new and upcoming series, which is my Rust project series. We're creating mini projects based on the chapters that we are reading in the Rust book. So this is my first time on Twitch, so I'm not exactly sure how to end this live stream, and hopefully it doesn't take me a long time. But I'm so glad that you came and shared this time with me to go through these books. I'm also learning, I would say maybe more of an intermediate Rustation, and I intend to get even better, and I want to be a master at my craft, and I want you guys to be a master at your craft as well. So stay tuned for the next live. I'll see you then. And hopefully this stops streaming.